All right, we are in AP Calculus AB. This is the key for worksheet 10-1. There are only 3 of these worksheets to do, so it's going to go fast. All right, so we have this graph. This is a graph of f prime, which is nice because when we need to find f of -3, and I'll write this out here as well, f of -3, as we saw in our notes, is equal to your start amount, which is 3. Let's label it. Our start amount is 3 plus your change, and the change is going to be the integration, or the integral between 0 and whatever the time is, -3 in this case, of the prime, of f prime of x. And this is f prime, so it's going to be, let's say, f prime of, it is x in this case, not t, f prime, cannot write, f prime of x dx. All right, so obviously this integral is backwards because it needs to go from more negative to more positive, so I need to flip it. So I need to say, okay, this is going to switch around a little bit here. Let me zoom in so I can actually write a little bit neater. So this is actually going to be equal to, I still have that 3 out front, but now I'm going to say minus the integral of whatever -3 to 0 of f prime of x is, dx. All right, so I need to find what is the area under this curve between -3 and 0. So between -3 and 0, so I'm trying to find these 2 areas here. And note that some are positive, some are negative, some are above the x-axis, some are beneath. So if I'm above the x-axis, that's positive. So this is a distance of 1, distance of 1. 1 times 1 is 1, and then half of that because it's a triangle. So this is an area here of positive 1/2. Down here, we have a triangle that's going to be negative, so it's 2 by 2, which is 4. Half of 4 is 2. This is an area of -2. All right, so this total area between -3 and 0 is -1.5, because 1.5 plus -2 is -1.5. So I'll say this guy right here is -1.5, -1.5. So what I really have is 3 minus -1.5. And double negatives make a positive, so it's really 4.5. And box it. Next, I need to find f of 4. So it's going to be the same setup again. I'm going to say f of 4 is equal to the same start amount, plus the integration, or the integral, from 0 to 4. And I don't have to flip this one, luckily. So this is still f prime of x dx. I just need to figure out what is the area between 0 and 4. So I come over here between 0 and 4. Okay, so it's kind of important to know what area I'm talking about. Am I talking about that area right there? No. I'm talking about this area right up here. So how do I find that area? And let me make a cool little diagram for you guys. So really what we are after is if we find the area of that rectangle and we subtract the area of this semicircle, it's not the best semicircle, that will be equal to the thing that we're trying to find, which is this combined composite shape. Let me, that's as good as I'm going to get. This area right here. So what is the area of that rectangle? Well, I'm going to say, okay, that's 2 by 4. So that has an area of 4. And I'm kind of ignoring the fact that it's a negative for now. I know that my final answer will be negative because it's below the x-axis. So I'm just going to assume they're all positive for now. And this is a semicircle, literally a half circle. And the radius of that circle, I know that the center would be here. The radius goes up 2. So it's a radius of 2. So I'll say r is equal to 2. Pi r squared means that this is 4 pi, but half of that is 2 pi. So the area of that semicircle is 2 pi, so 4 minus 2 pi, therefore this is 4 minus 2 pi. But remember, that is the area, but it is negative because it is below the x-axis, so I need to say that is a, let's distribute the negative right now. So if I have a negative here, that's going to be -4 plus 2 pi is the actual area that I'm looking for. So I come down here and I say, this right here we just found was, wait a sec. Yeah. That should be 8. I'm like, that seems too small. Yeah, so it's 2 by 4. Yeah, that's 8. My bad. Let's come fix that. Fix. This should be an 8. 8. And then this should be 8. Therefore, that should be a -8. All right, -8 plus 2 pi. That is -8 plus 2 pi. So our final answer, 3 plus -8 is -5. So our answer is can do this in a slightly different color, is negative 5 plus 2 pi. Final answer, box it. All right. We're on to, I guess that was question number 1. I should be labeling these. Eventually one day I'll get these labeled nice and neat for us. Number 2. Ooh, lots of cool shapes happening here. We are given a graph of g prime, which is going to be helpful because we're going to take the integral of that to find any change. So g of 3. What is g of 3? G of 3 is our start plus change. What is our start? Does it say anywhere in here? Oh yeah, so our start is 5. So I'm going to come over here and say this is going to be 5 plus the change. So the integration between, or the integral between 0 and 3. Again, where does this 0 come from? It comes from the fact that I'm starting at time is equal to 0. So this is going to be g prime of x dx. And I need to find what is the area between 0 and 3 on this graph of g prime. So between 0, so here's 0 and 3, 1, 2, 3. So what is this area right here is the real question. So I have a quarter circle and a half triangle. How do I find that? Well, let's find the area of the entire circle first. So this circle, again, is 4 pi because the radius is 2. 2 squared is 4, and it's pi r squared, so pi times that 4. So the whole area is 4 pi, and if I'm talking about a quarter of that circle, that's only pi. And then I need to find the area of this triangle. It's 1 by 3 is 3, and then half of that is 3 halves, so 3 halves. So this full area that we just found right there, this full area is pi plus 3 halves. Pi plus 3 halves. And if I add 5 to that, I'm really adding 10 halves. I'm going to get 13 halves. So this is going to be equal to 13 halves, or you can say 6.5 too, I guess. 6.5 plus pi. Final answer, box it. All right, what about g of negative 2? So I'm going to have to probably flip this one. G of negative 2. Again, it's always start plus change. So start is 5 plus change, the integral between 0 and negative 2 of g prime of x dx. All right, well that's a problem because these are backwards. So if they're backwards, I need to change this into the start 5 plus, no, not plus, minus now, the integral between negative 2 and 0 of g prime of x dx. Okay, so what is this area between negative 2 and 0? Between negative 2 and 0, oh, we already know that the quarter circle is pi. This is also pi. So this integral right here, that's pi. So the answer is 5 minus pi. I think I'm doing that right. 5 minus pi, yep. This is equal to 5 minus pi. Final answer, box. On to number 3. This is a calculator problem. So let me pull up my... I got my other calculator to kind of work. I wonder if I should try it again. I've been trying all year. It's never... Has it ever worked one lesson? Let's see if it'll pop up here. Hey, it looks nice. Okay. Let's try out our fancy-pantsy calculator. So let me zoom out here. So here's our f prime. That means I need to set my y equal to... Is it not going to work? There it goes. Oh my god, why? It was just working over the week. Okay, well, let's go back over here and do the old-fashioned TI-83 plus. The reliable Wabbit EMU emulator. E to the power of negative x divided by 4, end parentheses for the power of, now that's going to be times, so I don't need to write anything, sine of x squared. Okay, we have our f prime typed in correctly. Keep track of your parentheses, make sure they're all typed in correctly. And I need to write an equation for the line tangent to the graph at x equals 2. Oh, do we even need a calculator? Let's try as much as we can without a calculator. So I need to find at x equals 2, that's really, what is f of 2, right? So it's going to be y minus block is equal to the slope times x minus the x coordinate, which is given to us, which is 2. Okay, so to find the slope, well, we have the slope, f prime. So I just plug in 2 into this equation. So this is f prime of 2, and we use our calculator to find that. And we know that this is f prime, so if I just plug it in, if I do bars right, enter, enter, y1 of 2, that is f prime of 2, which is negative 0.459 rounding. So negative 0.459, negative 0.459, so negative 0.459. And how do I find this? This is the y coordinate. That's going to be the hard bit. So this is the hardest piece. To do that, I'm going to say this is going to be, the thing that goes in here is f of 2 goes in here. And f of 2, to find that, that's an accumulation integral. So that's going to be our start plus change. Fundamental theorem of calculus. What is our start? Our start is 5. Our start is 5, so I'm going to come back down here and say this is going to be 5 plus the integral between 0 and 2 in this case, because don't know what's happening there, 2, of f prime of x dx. Okay, so what is that integral? Well, I'm going to come back down here, math 9, integral of bars right, enter, enter, y1 with respect to x from 0 to 2. And I should get about 5.623, yeah. So 6.623, and then I have to add 5 as well. So 5.623. So this is equal to 5 plus 0.623, or 5.623. So come back up here, 5.623, and there's our final answer. I don't need to box it because it's already written down. Whew, all right, that was number 3. On to number 4, on to the back. All right, we have a function. We have our start initial condition, whatever you want to call it. I'm going to call it the start. And we have a function that we're going to have to plug into our calculator. Let's go ahead and do that now. Let's clear out of view. It's going to be sine of x plus 1 over x. All right, so we have it plugged into the calculator, and we need to write, again, tangent line equation. X is 0.3. So just like we did before, y minus box is equal to box times x minus box. And we know what that x is. That's the x coordinate is just 0.3. So I'll say this is 0.3. And this is going to be f prime of 0.3, and this is going to be f of 0.3. So f prime of 0.3, again, you can just find that in the calculator. You just go vars right, enter, enter, your y1 of 0.3. And we get negative 0.47. So I'll write it down here. Negative 0.472, negative 0.472. Okay, for the f of 0.3, that is the harder piece, and I don't have enough room down here, or do I? Yeah, I can just use this space. So that's going to be f of 0.3. That is going to equal, I have to do my start. What did we say our start was? 2. So 2 plus the integration, or integral between 0 and 0.3 of f prime of x dx. And that's going to be what? I'm going to do it all at once. 2 plus math 9 vars right, enter, enter, y1 with respect to x from 0 to 0.3. And we get, is that going to be 1.546, I'm hoping? Go calculator, go. Oh wow, it's taking a while. Let's just go off of last year's key, which is 1.546, 1.546, 1.546. And did it catch up to us? Still working on it, but that should be the answer. I'm going to move on to number 5 while we're waiting for that guy. That was number 4. This is going to be number 5, starting with this graph. Okay, have this cool little graph, and we need to find g of 3, g of negative 2. So again, zoom in here. What is the definition to find g of 3? g of 3 is going to be given by the start. What is our start condition? Here is our start. Our start is 5, so this is going to be 5 plus the integral from 0 to 3 of g.
Notice that g of 2 equals 5. Does that change the start condition?
G of 2. Oh, yeah, it does. Yeah, thank you. Our start condition time got moved over. Yeah, thank you, Arrow. So from 2 to 3, did you log it?
No.
You never logged them. G prime of x, yes, x dx. All right, so the bounds between 2 and 3, where do those guys live? So 2 is right here, and wait, 2 and 3, really? That's a weird spot. Okay, yeah, so what is the area of this segment right there? Archery competition is in 15 minutes. Cool. So I have to figure out what that point is. It looks, if I eyeball it, it looks like that's going to be -1, but how can we be sure? Well, we're given these 2 points. Well, I know it goes through the axis there, so I guess I could use that as a point too. But I have this point down here, this point, I move right one, down one, right one, down one. Yeah, that actually makes sense with our slope. Our slope should be -1. If you don't know what that is, you can use our old-fashioned formula, which is delta y over delta x. So our change in y. You can also use the y2 minus y1 all over x2 minus x1 formula. And that is going to be, what is our y2? Our y2 is going to be -2 minus 1 all over x2 is going to be 4 minus 1. I'm using these coordinates here and here. And then you get -3 over 3, and that simplifies to -1. So the slope is indeed -1, which means if I go right 1, I should be going down 1. This point, long-winded way of saying it, is 3, -1. 3, -1. Which means this is a 1 by 1 triangle, and 1 times 1 is 1, divided by 2. This has an area of -1/2. Whew. All right, so coming back down here, zooming in, this right here has an area of -0.5, which means our final answer is 4.5. Next one, g of 2. It's again our start plus the change between 2 and 2. Oh, hey, that's kind of nice. That it cancels out with whatever that was. Oh, darn. I thought it was easy. Yeah, thank you, Gio. Log it. G of -2. That's equal to 5 plus the bounds from 2 to -2, g prime of x dx. Okay, so I have to flip this one around. So this new integral is going to be 5 minus the integral from -2 to 2 of g prime of x dx. And between -2 and 2, where are we talking about? So from -2 right there all the way to 2. Oh, -2 to 2. Ugh. Sorry, guys. -2 to 2. There we go. Dang it. Really? There? Yeah, that's a not fun point. Okay, there's our correct bound. So we need to find the area of this triangle and the area of this weird triangle. And man, that is going to be a hard point to find. Or is it? Actually, I think if we eyeball it. It looks like it's going to be -2. How can we check? Again, we can check the slope of this line. You could calculate it. Let's do it the long way. Actually, let's do it the shortcutty-ish way. So if I go right 2, that means I go to -1. And if I go up to, okay, so I have to go, -4 divided by 2 is -2. So negative, that cancels out. Cool. So this has a slope of 2. I know that was done lots of mental work, but you can just use the same formula that we did over here to find that this is a slope of 2, which means if I go left 1, I go down 2. This is indeed at the point -2, -2. Which means this triangle has a distance of 2, distance of 1. 1 times 2 is 2. This area down here is -1. This area up here, it's 3 times 1, which is 3, so 1.5 for the area of that triangle. I'll circle that. So I have a -1 and 1.5. That means I have a total area of just 0.5. This integral is 0.5. This integral right here is 0.5. 5 minus 0.5 is again 4.5. Is that right? That's weird. My answer key got it wrong from last year. That's cool. So we found a mistake on the answer key. This should be 4.5 again. You got 5.5.
What does the answer key say?
The answer key says 5.
It says, oh my god, we have got different answers.
Well, so Arrow, do you agree that this is -1 and this is 1.5?
Yes.
Therefore, adding these together gets us 0.5?
Yes.
Okay, and then we had to subtract because we had to switch them around?
I think it was the subtraction that I missed. Yeah.
Ah, okay. Cool. All right, we are on our final problem. This is number 6, right?
Yeah.
Number 6. What's going on? Yes, the archery competition phone, go away. All right, so another graph, and okay, what is our start condition? Again, we're defined by this integral. We start at 2, and we don't have any start condition. Yeah, so g is the integral. So we already found the integral, so we just have to plug it in. So we can say g of 1 is equal to the integral between 2 and we plug in 1 into this upper bound 1. So it's 2 to 1 of f of t dt. Okay, so we have to change this integral around. So this is going to be the negative integral between 1 and 2 of f of t dt. And between 1 and 2. So between 1 and 2. So I see a rectangle here with an area of 2. This is a rectangle that's 2 by 1, or a triangle that's 2 by 1, so an area of 1. So this integral right here is just 3. The integral is 3, so our answer is just -3. And our final problem, we're almost done. G of 0. G of 0 is the integral between 2 and, plug it in, 0, f of t dt. Okay, we need to switch them around again. So negative integral between 0 and 2 of f of t dt. And that is now equal to, okay, so from 0 to 2. We just need to add on this additional triangle, and that has an area of 1. So just add on 1, and I get this integral is 4. So our answer here is -4. Whew, all right, that concludes worksheet 10-1.